What's up everyone, Mike from FlightClub. In this video, I'll be building this skeleton PROton. Originally, I was going to do a build for a racer PROton and then a long-range freestyle PROton, but then I realized if I can configure the quad correctly, I can have one PROton that can be either a racer or a long-range freestyle quad. This PROton can be switched over from a racer to a long-range freestyle by just changing out the arms, props, and battery combination. This PROton is using the Acon AK32 4-in-1 ESC that's rated for 35 amp constant and 45 amp burst. It runs on BL Heli 32 and is rated for up to 6S. I've been using this ESC in pretty much all my builds and I haven't had a single issue so far. For the flight controller, I've been testing out a bunch of flight controllers over the past few months, and I finally settled on the Helio Spring. The Helio is a F3 and a F4 dual processor flight controller that has BetaFlight, or should I say ButterFlight OSD, 5 UARTs, and runs natively on ButterFlight. I know there's some drama surrounding this board and ButterFlight, but I chose this setup based on the features, ease of install, and most importantly, flight performance. And this thing flies really good on ButterFlight. For the camera, I will be using the Foxeer Aero Micro Pro. I tried the Predator, but I felt like the low light performance was not as good as the Pro. For the VTX, I'll be using the TBS Unify V3, which has an output of 25 to 800 milliwatts. 25 is required in some races for racing, and then the 800 milliwatt you can use for like long range or whatever. And then for the motors, I will be using the T-Motor F40 Pro V2 1600 kV. On a 4S setup, I normally fly around 24 to 2500 kV. That equates to about 40,000 RPM. 16.8 volts, which is 4S voltage, times 2400 kV. You get around 40,300 RPM or something like that. So for 40,000 RPM on 6S, you would need a 1600 kV motor. 25.2 times 1600 is about 40,300 something. So if you normally fly with 2600 kV motors on your 4S setup, you might opt for like 1750 or 1900 kV motors. But for me, 1600 kV on 6S is plenty fast for me. So the reason why I didn't just go with a 2400 or 2600 kV on 4S is for the versatility. Using low kV motors lets me choose if I want this quad to be a racer or a long range quad. For a racer, I would run this setup with 5-inch arms, 5-inch props, and on 6S. For the long range, I would run something like 6-inch or even 5.5 was on here with 6-inch props, and then run either 4 or 5S. If I want to just cruise around a park and explore, I can use a 4S 1800 pack, and that'll get me around 8 minutes of flight time of just easy cruising around. And on a 5S, you get a little more speed. On a 5S 2200 milliamp pack, you'll get around 6 minutes. With a 4S setup and 2400 kV motors, the max flight time you'll probably get is maybe 4 minutes tops if you're flying really easy, and you wouldn't be able to fly 6S with those motors. You probably could, but the motors would get super hot. So I went with the 1600 kV because it's fast and they're super efficient. So in this video, I will be using the TBS Unify or TBS Crossfire Nano, this little tiny receiver. I initially put off using the Crossfire because I thought it was confusing to set up. The manual is kind of hard to follow, and the videos online were kind of confusing. But the Crossfire is actually really easy to set up. I'll show you later in this video. A lot of racers are actually using the Crossfire in race quads due to the low latency, and for a long range quad, even with the lower power Micro TX that plugs in the back of the Taranis, you can easily get like a half-mile range. It can probably do even more than that, but I just really haven't had a chance to test it. And of course, if you're going to use the Crossfire, use the Immortal T antenna, this little thingy right here. When I first built this quad, I used that stock stringy antenna that came with a Crossfire, and when I was testing it, I was flying around my house and the quad went into failsafe probably just 200 feet away and almost crashed into someone's house. So don't do that. Use the Immortal T antenna with that diamond antenna that goes on the TX. Alright, so let's get on with the build. So first thing we're going to do is we're going to prepare the Crossfire Nano to be mounted on the bottom stack of the flight controller. So the CNC plate is designed to have a little slot right here, have a little opening to put any kind of RX. So first we're just going to prepare the Crossfire Nano to be mounted on the bottom of the frame. These are the wires that come with the Crossfire, and we're just going to wire up the 4 wires that you need on the Crossfire. Alright, so on the Crossfire, these are the 4 pins you need. You need channel 2, 1, 5 volt, and ground. So I'm just going to wire up the wires right now. On the channel 1 and 2, it doesn't really matter what color you use, as long as you connect it correctly. So I'm just going to do this really quickly. So I'll just put yellow as channel 2. So these wires are already pre-tinned and cut from TBS, so it makes hooking up really easy. 5 volt. Ground. Alright, so this is all I did. I just connected the 4 wires, channel 1, 2, 1, 5 volt, and ground. And then, so before we heat shrink it up, I'm just going to put on the antenna, the Immortal T, and then just kind of bend it this way. And then you'll see why in a little bit. Do like this, and then I'll just cut a little piece of heat shrink. The reason why I'm pointing the antenna back, or the UFL connector for the antenna back this way, is so like the heat shrink can hold it down. So it makes it nice and secure, so the wire won't come out. And then once I have it like that, I'm just going to heat shrink it, close it up. Alright, so I just heat shrinked it, and this is what it should look like. The wire, because it's smashed on with this heat shrink, the UFL is not going to come off. And then just to make it easier later, I already have this little cheat sheet that I made for the build. This is the cheat sheet that'll come with the build kit that I'll have for this. And then I'm just going to go ahead and cut the lengths for the Crossfire. And the way I'm going to mount the ESC is going to be upside down like this. So the receiver is going to just double sides tape on the bottom of this, on the ESC, on this where this little gap is. And then you can move this antenna back and forth to adjust how much wire you need. So this is what the ESC should look like once it has the RX mounted on there already. Now we can mount it onto the frame. So the PROton has a nucleus plate. So the nucleus plate is a CNC aluminum machined part that has these little orange grommets that go into these holes for the flight controller. So this completely isolates any vibrations that that can come from the motors and mess up the gyro on the flight controller. So you're just gonna pinch these little grommets and just put them in the holes. And then ever since I started designing frames with this butter mount, the way I like to mount the stack is just with one long metal screw that goes all the way through the whole stack. So that way you never have to worry about broken standoffs or anything like that. And plus with the butter mounts, you don't have to worry about any of the hard surfaces like the metal touching the frame, because it's completely isolated. Alright, so once it's on there like that, you can put the ESC like this. We're going to push the antenna down through the bottom. And then, so to mount my antenna, I'm going to use this little part that I designed specifically for the Protons. All it does is you just slip it on like this. And then when you sandwich the arms and the bottom plate on here, this little plate will hold the antenna, and it won't go anywhere. So I'll go ahead and just do the first one. So the cool thing about the Proton is that the CNC plate already has these threaded, the holes for the motor screws are already threaded, so you don't have to worry about any kind of nuts or anything to hold on the other side. You simply just screw it right into the frame. Like that. And then just put the rest of the arms on. Alright, so once you got the arms mounted on here, as you can see, the frame is really easy to put together and everything's well thought out. One of the things that really annoy me is like when you buy a new frame, a lot of the designers, they don't even pay attention to like where you put the components. Well, in this frame, you don't have to worry about that because everything has a spot. Doesn't matter if you're using a regular receiver or something like a Crossfire. It's all planned out. So once again, I'm going to use this little cheat sheet that I made. Since I'm making this quad a switchable quad from 5 to 6 inch, I'm just going to cut the motor wires for 6 inch. But if you're just building this quad specifically for a race, I would do just a 5 just to save weight, because these extra lengths on these wires can add weight. So this cheat sheet will come with the kits that are that I'll have available on my website. If you're not using these, or if you're not building from the kit, you can just eyeball these and cut them when you mount them onto the frame. Alright, so now that you got the motors mounted onto the frame, you can solder it onto the ESC. So first, I'm just gonna pre-tin, or actually, I'm gonna add my own solder to these. The ESC pads that came from the factory, because for some reason the solder that they use is like really hard to melt. So I found that just by adding my own solder here, it'll make it a lot easier for my motor wires to go on here. Make sure it's nice and melted. Alright, so I'm just going to start from the shortest wire and then go left to right. So anytime I'm doing any soldering, I always leave my iron at the hottest setting, because I found that what really destroys solder pads is not the amount of heat, but how long you leave the iron on the pad. So if you're using a really hot iron, it really doesn't take much for the solder to melt. And for the ESC pads, I always melt the ESC pad, and then when it's liquid, I put the wire on there, and then it should melt the solder that's on the wire. It's really hard to do with a camera right in front of my face. So next we'll prepare the Helio to be mounted onto the frame. The cool thing about using the Helio with the AK-32 is that both of them have this little harness. The Helio comes with an 8-pin harness, and the AK-32 comes with a 10-pin, but you're not going to use a 10-pin. All you're going to need is the 8-pin that comes with the Helio. So all you're going to do is on the Helio side, you're going to leave everything as is, but then on the ESC side, you're going to de-pin all these pins, and then you're just going to rearrange the wires according to the schematic I have on my website. Once you have it rearranged, you don't have to worry about soldering up ESC signals or soldering up a power and ground or a current wire to the Helio. This harness will have everything in there already. And the schematic that I have on my website is for this setup, is to have your AK-32 flipped upside down with the ESC, or I mean with the battery pads pointing to the back. Because if you have this orientation any other way, that schematic's not going to work, because the ESCs aren't going to line up with how they're laid out on the board. So before you do this, I would mark one of the sides on the connector, just so you know. Like, I'm gonna mark the ESC side black, because once you have it rearranged and you plug the wrong side into the the wrong connector, it's gonna kill your board. I did that on accident one time. I wasn't paying attention. I had the harness flipped backwards, and when I powered it up, it killed my Helio. So make sure you mark one side so you know which side is which. And then one more thing, the harness that we're using is an 8-pin from the Helio. I mean from the from the Helio, but the AK-32 is a 10-pin. So all you're gonna do is you're gonna put this harness right in the center of this 10-pin harness, and you're gonna leave out the top and bottom pins. Yeah, just make sure you have it plugged in correctly, because if you have it plugged in wrong, your pins are going to be shifted incorrectly. Alright, so I'm just going to go ahead and de-pin the ESC side. I'm going to pull out all the wires. All you do is get a little sharp thingy and lift the little plastic thing, and then you can pull the wire out like this. Just lift and then pull it out, and just do the same for all of them. Alright, so as you can see, I've got this the ESC side de-pinned, and then I'll just show you how to do the first one, but just follow the schematic on my website and it'll show you exactly how what order to connect the wires on the ESC side. So I'm just going to start at the top. According to the schematic, this is pin 1 red, this is the power, and it's gonna go on the second to bottom pin on the ESC side. Oops. It helps if you push these little plastic things in, it grabs the head better. So this one, the power is second to the bottom. Just like that. So once you got that, just do the same for all the other pads. Alright, so this is what the harness should look like once you have it rearranged. Once again, the left side, or the Helio side, is all stock, and then the ESC side goes green, white, blue, green, yellow, white, red, black. I'll have the exact detailed schematic on my website if you're interested. So once it's arranged, I'm going to make sure I have the ESC side. I'm going to go ahead and plug it into the ESC, but make sure you're plugging it dead center, and you're going to leave the top and very left and right pin empty. Bam. So just gonna plug it in like that, and we'll leave that as is. Alright, so next we're gonna get the Helio ready to be mounted on the board. The Helio comes with these, or actually it comes with these purple dampeners, but I'm gonna use the ones that my custom butter mounts, because they're a little bit thicker, and we're gonna need that extra space for under the flight controller later. I'll show you what I mean later. Okay, so for the sake of the video, I'm just gonna go ahead and do the physical build of the quad and then go into the ButterFlight part. But normally for any new build, before I do any kind of soldering on the flight controller, I always plug it up into Betaflight or ButterFlight just to make sure it'll connect and there's nothing wrong with the board. So we're just gonna hit this little 5-volt jumper. Boy, these pads are freaking tiny. Oh, that is way too much solder. It's hard to do this when you got a camera right in your face. I can't get close enough to do this. Alright, I'm gonna need this solder wick. So once you got the Helio jumper set, you can mount it onto the board. So we're just gonna mount the board with the connector facing the back. But first, I'm gonna put some more butter mounts in between the ESC and the flight controller. I always use these butter mounts as spacers. They work better than standoffs. Alright, so just go ahead, or actually put the harness down first, because it's gonna go under. And put the Helio on, and then just connect it up. Bam. Alright, so once you got the connector set up or connected, you don't have to worry about ESC signals to the ESC or powering or anything. It's pretty much set up already. Alright, so next we're gonna set up the TBS Crossfire Nano. So the Crossfire has these 4 wires, ground, power, channel 2, channel 1. So to set up the Crossfire on any flight controller is super easy. All you have to do is pick a free UART and connect the channels 1 and channels 2 to the TX and RX. So I'm just going to use UART 3. So it'll be TX3 and RX3, and then I'll just this is for ground, and then this is power. Oops, I should have laid these out better. The Crossfire wires need to go under the board. So just put them under the board like that. Alright, so I'm just gonna power these up. So red wire is just gonna go to, oops, go to the power, obviously, and then I'm gonna put channel 2, which is this yellow wire, on the TX3, and then the channel 1, which is this white wire, will go on RX3, and then ground will just go to ground. Move this over here. Alright, so that's all you have to do is to connect the Crossfire on a flight controller. You just basically ground to ground. Red is on a 5-volt, and I have it selected on 5-volt, and then where's my, and then channel 1 which is the white wire, goes on RX3. Channel 2 will go on TX3. If you get confused on any of this setup, I have the exact schematic of how to wire everything on this quad on the website. So if you get confused, just go over there and just follow that schematic. It should be very easy to follow. So now we're going to get the FPV part ready to be mounted on the board. Once again, I'm just going to use this little cheat sheet. This is the wire for the Unify V3. This is the 5-volt version, not like the TBS Unify Race that I usually use, but we're just going to power everything off 5-volt. So I'm just going to cut the wire to however long I need. If you're not using this cheat sheet, you'll just have to eyeball it again. So smart audio, and this is ground and power. Alright, so that's all you need. And then this is the harness for the Foxeer Aero Pro. You're just going to use the end that has this little plug right here. So we're going to move all these wires out of the way, and then you're going to remove the gray wire, or actually this purple wire, because that's VSEN. This is for the OSD, and we won't be using the camera OSD because we're using the ButterFlight OSD. So just remove that, and then I'm just going to cut the length. This one you really don't need all that long. And then I'm going to splice and tin these ends. Alright, so I got the camera wire and the VTX wire spliced and tinned. So we're just going to install it onto the board. This is video. And then it goes power, ground. And then for the VTX wire, we're going to use TX5 for the smart audio. And then ground. And then power. And then video will be this wire. Bam, done. Alright, so the last thing we gotta do is mount the XT60 on the battery cable. I'm just gonna cut a little bit of this off because I don't want it that long. Cut it off and then splice and tin it. And then first I'm just going to slip on a little piece of heat shrink. It's going to go over the whole thing. Alright, so make sure I get the right. Alright, so now I'm just going to mount a cap. I found that mounting a cap on the XT60 cable is exactly the same as mounting it on the ESC. So I just mounted it on the XT60 cable because it makes it a lot cleaner. So I want it on top, so it's going to be like this. You got to pay attention to the polarity of the capacitor because it does matter. So I'm just going to bend this down and bend these in a little bit. It's going to sit just like that. Actually, I want it a little bit shorter, so I'm going to cut some of these leads off. And this, and then I'm just going to tin these the capacitor leads. And then just put a little bit of solder on the pads right here. Or actually on the XT60 cable. And then I'll just put the cap right on to the XT60. Bam, just like that. So I don't know if you can see that. And then I'm just gonna put this heat shrink right over all of this and then just shrink it up. Bam, just like that, nice and neat. Alright, so we're just going to do a quick test before we power it up, make sure everything is okay. I'm just going to use a regular multimeter and set it on the continuity settings. This basically tells you if there's a short anywhere. So when you first connect it up, you're always going to hear that short little blip, but as long as it's not like, you're good. Alright, so plug it up. And we are good. So at this point we're pretty much done with the physical build of the quad. Since this quad is running the TBS Crossfire, it takes a little bit more time to set up than, you know, like a regular quad running FR Sky. And also it's running the ButterFlight 32 ESC firmware, which takes a little bit more time to set up than ButterFlight S. I'm going to make this a two-part build for this quad, just to keep the length of this video shorter. So check back next week when we flash the Helio with ButterFlight, set up the ESC with ButterFlight, and I'll show you how to configure your Tyrannus to be used with the Crossfire, and then we'll finish building up the rest of the quad. So if you have any questions, just put them in the comments below or go to my website and put the comments there. I'll answer questions a lot faster from the website, and the full schematic on this build along with the build kit, which has the cheat sheet, all the little miscellaneous parts you need, will be available on the website. So I'll see you next week, and thanks for watching.